So today we will take apart the old printer, scanner and fax machine combo. It doesn't work anymore. Basically the printer head is not in a good condition. I tried to get it to work for some hours, but only managed to get the black color working, and given what such machines go on eBay, it's really not worth to put more effort into it, so instead I will just get the interesting parts out of it. So the main board is out. One interesting thing is that apparently from this machine there was also a version with a card reader, so it could print directly from memory cards. And as far as I can tell, there will not be much more logic inside, so I guess everything was placed on one board except for keypad and of course the primary power supply. I'm wondering how to get in deeper. The first part was quite easy, but cementing it further seems a bit tricky. So the power supply is covered by plastic from the top. And there is a metal sheet on the bottom, but it doesn't seem to have any screws. I'm not really sure how to get it out. Well, we can of course start with another part. Trying to get out the actual printer section. Oops, that's the waste container for used. So when it cleans the heads, then it will just pull the waste ink into this containment unit, which is just some paper, and that's it. Now, given that there is quite a lot of fresh ink from the head clean attempts from earlier on, I would guess I will continue the work using some gloves so that I don't get my hands completely colorful. But now I can touch whatever I want. It appears that the casing is just held on by clips like here, so that's quite a pain in the ass to open, at least if you don't know the right trick. And also many devices are just made such that they're not supposed to be opened once they are clipped together. Now, since we don't want to use the printer anymore as a printer, you can just go for a little bit medieval approach, just ripping off the clips. No, that didn't help much. I'm wondering where the buttons to be screwed down. Normally the usually the whole printer unit should be able to come out in one piece. At least it doesn't feel like it would be rigidly connected to anything else. So let's see, well, there might be another screw under here. Remove the head is not trivial, as there is a block that snaps into place when it's in this position, and you need to pull a solenoid to open it. But since it's completely disassembled, this is not an option. Okay, there were no more screws. That was it. And it's out. The only thing connecting it is the ink tubes, and with one connection going to a small micro switch. One of the nice things about this printer apparently was that it doesn't have any chips built into the ink cartridges. It just checks mechanically if there still is some ink inside or not, using this optical gauges here. So basically, as soon as a swimmer which is built into the cartridge goes down, then it will interrupt the light gauge. I'm not sure what the right English term is, and that would be it. This is a switch that checks whether the black ink is in. For the other inks there's apparently no such sensor, which is interesting. Yeah, and here you see how it's made from below, so basically just the ink goes here, then it goes into the tubes and then continues to the printer head. Before we continue with the actual printer unit, I will try to somehow access the other part here, where there is the fax connector and the power supply. It could be all in one PCB, or maybe they are multiple in one case. We will see that shortly, but still have to find out how to access it. Maybe just click in somehow, but actually it's more likely. So it really is just clipped in. Yeah, that was it. So apparently the power supply is on one PCB and the fax module on another. There are only 4 wires connecting the two parts. So let's take a look. I measured earlier the power supply gives you 31 to 32 volts, and then there is a DC-DC converter on the main PCB here that provides more suitable voltage for the rest of the system, about 5 volt. And there are some linear converters also for lower voltages. When you look on the main board, you have here a section which is marked, which is separated from the rest, and has quite a large clearance. And if I remember correctly, this wire went in here, which goes to the fax interface. So apparently the voltage isolation from the line, in case there is a over voltage on the telephone line, is done on the main PCB. So if anything happens, you have to replace the whole electronics of this thing basically. When I look on it, I don't see any voltage connection going in here, but that's possible because the line provides about 60 volts when it's connected. There is one transducer here where data can be exchanged between the two sides, between some chip that handles the fax features and the main processor. Well, now let's just look inside the actual line interface part. Actually, there might be not so much in, since almost everything that you need is already here. There is even a rectifying bridge that you need in order to work with the telephone lines. For once, when there is a ring signal, then you will get alternating current and on the line, and further then yeah, there's not much. And further, of course, you cannot guarantee that when you put in the plug that you will always get the one or the other polarity. It can be basically arbitrary. So when we look here, we see that the interface itself really is quite trivial. There is a small relay which is connected to the other wire, the black one, which goes in here. The relay just switches between well, that's actually a good question. I guess it will just emulate the picking up of the earpiece. There is a connector also here, which basically is designed to be outgoing. So you could plug a phone in here. It is connected to some wires that are also present on this plug. In Austria, you have this longer plugs where you can push up to 3 side by side, one for telephone, one for the fax machine, and one for the this machine that records messages, however it's called. But here apparently this connection is not intended to be used, as there is a plug inside, and the relay will only switch pins on this connector. So when the fax is not active, the line is comes in and then comes back out and then goes to the phone. And if the relay switches, then basically it picks up the earpiece, so to say, and then you have your data on these 2 wires, which then go into the part which does the more interesting things. Now, power supply, as said, provides only 1 voltage, and it's apparently it's accordingly trivial build. One thing that is not so useful about such power supplies is that mostly in your own projects you will not need 31 volts for anything, so you will need another DC-DC converter. So unless you have a very power-hungry design and maybe want to use multiple DC-DC converters and only one main supply, that is useful, but in the most cases you just want to power a microcontroller and maybe a few relays or other not very power hungry parts, then this will be an overkill. The power supply is made quite nicely, so you have a nice large separation between the live side and the low voltage side. There is an optocoupler to shut down everything if some error occurs, and I don't know if you can see it, but there is actually quite some discoloration on the board showing that it got quite hot in all the years of operation. The fuse here is 3 amps, so we will have 31 volts at 3 amps, so almost 100 watts, which is actually quite nice. You could use this power supply together with a fitting constant current supply to, for example, power some high power LEDs, although when I remember correctly, most of them probably will need another voltage, but you can get very nice constant current sources that basically take any input within a certain limit, of course, and provide. They have a built-in DC-DC converter, and they provide the right voltages for the LEDs. And these parts are not so expensive, so it might actually be also an interesting thing for later. Now let's take a closer look on the actual printer. The mechanism down here is basically a pump that will suck on the upper part, which connects to the printer head. Oops, it's dripping on me. To the printer heads. So here it will create a under pressure, or it may also be just a switch that selects to which of these pipes the main pipe is connected. Both is possible at this point, as I don't looked inside yet. But anyhow, the point is it will then just create a under pressure in this position here and try to suck out through the nozzles of the printing head in order to clean it, which is well, wasteful for the ink, but apparently good for your print quality. I'm wondering how I can unlock the head so that it will move, so it will start moving. Basically, I just need to rotate the right thing, and then it will do something. But so here's the cleaning part. Interestingly, there are actually a few. I would guess the lower part will just create a lower pressure and sucking. I don't think that it will actually switch between the different connections, but we will see that once we progress further with the disassembly. It will be probably a very messy thing due to all the ink that is still around here, so well, it's really quite messy. There are actually quite a few nice things you can get from a printer. Of course, it depends on the actual design and implementation. In some printers you have, for example, very nice sturdy metal bars that you can use, for example, to build an own 3D printer. In this particular unit, at least the good ones are missing, so here you have basically a slide that moves the head. And in more expensive designs, this would not just be a slide, but actually the head would be fixed on a very nice polished axis. But, well, apparently not here. Yeah, I would really guess that this will just be some sort of improvised pump, since both tubes that go to the collector are connected here, and there is another part that could create suction, so that will just either create suction all three, or maybe it will create a little bit suction on each of those connectors. Interesting thing to notice is that one tube is missing. I don't know if you can see that. So, well, I guess it will really create suction one, then on the next, and the next, and then on the next, and then will repeat the procedure from start. Because if it would just create suction all three at once, then of course the position where the tube is missing would be a leak, and then you would have no suction at all. Okay, so what else interesting can we get from this old thing? I'm wondering if it is easy to disassemble it further, because as it looks, then it was put together and then the metal bars have been put through, so disassembling it might be a little bit more work than expected. And of course the other question is if there are any interesting things inside, so actually there will not be much, in my experience, interesting. There is one more motor that makes a rotation. Then you have here, so there's one, the motor is here, that rotates the whole paper feed, that drives the paper feed. You have an encoder wheel and a small linear encoder that measures the rotation. Interestingly, in all these inkjet printers, you have DC motors, so they really need to, the current that you put through have to be feedback in real time against the actual rotation velocity, otherwise you will just get a more or less random result, which is not the desired thing. And the point here being that the rotation speed of such motors depend not only on the applied current, but also on the resistance to rotation. So if you have a system which is very well defined, then of course you will get a decent speed control, but usually there are too many unknown factors to your mechanism. I mean, if the level of lubrication can change that, so in the end you will not get a very well defined rotation speed, and especially for a printer that is not acceptable, so you just use some real-time feedback and adjust your motor driving power. I'm not sure why they choose to do this. I would guess that it gives you a smoother or faster operation than using a stepper motor, which would be very deterministic. Since these things are made to work in an office, I guess the noise level is one of the design considerations, so you really may not want to use a stepper that might create more noise than a standard boring mechanical DC motor. Okay, there's the second one. Now what I would also like to get out are is the wiring, because when you're building nice small projects, it's always nice to have some wires with small useful plugs on the end, and buying those separately and crimping is always well, either expensive or it takes time or etc. And just getting it in a ready-to-use fashion from an old printer is more convenient. Yeah, such things should really be only done with gloves, because it's really starting to be a mess. Everywhere were ink and lubricant, so it's not really nice. Well, that would be a nice access if it would not have this very rough lining here, so well, I guess I will not keep this. Okay, we have another ink ketchup or well, container for unneeded ink that was also used for cleaning the heads. When the printer starts printing, using the mechanism I showed earlier, it will clean the heads if if the printing quality is bad. But if you just print a normal piece of paper, it has a small pad that is exposed from this large waste container, on which it will like discharge the printer head once before starting to printing each page. So that's that. Then we have also some nice springs which can be useful. We also got a very large spring. I don't know if that one will be useful for anything, but those are definitely very nice. They actually are really nice. One could use them, for example, in a 3D printer to push against the filament. And I guess the rest is really not longer interesting in any way. So let's take a closer look on the head. There is also a linear encoder. In this case it's a stripe and not a wheel, as here. And then of course there is the printing head itself. Somewhere one more clip that is holding it down. Yeah. Well, there everything is glued together, so I guess that will be the end of this, taking apart this part, although I would like to get to the encoder. Okay, interesting. So we have an encoder here and some sensor here. I guess the sensor is to check whether the paper actually has been pulled, because it is made up of a light emitting diode and a photodiode, so it is looking on some back reflection. There really is not much more on the PCB, just a capacitor to ensure that the voltage supply for the printer will be as smooth as possible. The connection here was not soldered, but there is a ZIF connector for a wire, so you can push it in or pull it out, and then it's just glued over. So well, I haven't broken anything yet. Interesting thing about this type of printer heads is that you really can print almost any liquid with them if you have the time to play around. I'm wondering whether the data that goes in here is in any way digitally encoded, or if it basically you have just like a common ground and one pin for each nozzle. But I guess the amount of nozzles is, as far as I can see, much higher than the amount of pins, so it will not be that simple, and I guess finding out the pin connection is not something that is doable with a reasonable effort, so we will just get rid of it, of this part. And what we are left is a nice thing you can use to move something left and right, but since there is no very good guiding, it was just really lying on two rails, and that's it. I guess the amount of things you can actually build with these two pieces is somewhat limited. Although, of course, this I don't know the right English terminus. It's basically a belt with teeth that you can move quite deterministically, because it will not slip when it rotates in comparison to normal belts, which could slip potentially. But I will keep this thing. Maybe I will find a use for it. If I have to move something that is not very heavy, that should be just fine. Okay, now we will take a look on the scanner part of the device. There are also quite nice things you can find in. The likelihood of finding a nice nice straight metal axis inside are actually not that bad, because when you are recording you really need to have a good precision. Oh, do you see? No, there already is one in, but a very thin one, and well, then we will see what else we can find inside. One thing that also may be interesting is the display. It looks like a probably it's just a standard text display, but I'm not sure what interface it has, so I may play around with it at some later point. I'm not sure if that will fit through due to this. Oh, it will choke, but it just went through. I would start with the part that is used to pull in the documents if you want to scan more than one page. But there should not be many interesting things inside. Probably really just a motor and maybe a few switches. The way these things work is just the scanner head moves here, and then the paper is just swiped across it. So there are no two scanners in such designs. This is actually possibly quite nice. Yeah, I will keep this definitely. And what also is always quite smart is just keep all the screws you can get, because you will have a lot of different sizes, and if you 3D print something then that you want to like print in multiple parts and then put together, having a large collection of various screws will come in very handy. That's better. I shifted a few things out of the image previously, so sorry for that. But I'm still learning how to make nice videos, so be patient. There are two clips holding this down on the front, but there seems to be also something that holds it down in the middle, but I kind of don't see it, so I guess I may just pull a bit stronger. Okay, I know what's holding it down. This axis has to be removed before one can pull the thing off, but this does not appear to be that trivial. Maybe this. Yeah, perfect. You have to there is a pin, you have to rotate it down and you can pull out the axis, which is actually quite nice. Well, it's at least nicely straight, so that's already a plus in comparison to the I mean straight, they are all straight, but I mean there is no lining on it, so you can use it directly, although there is a pin stuck in. I'm wondering whether I can remove it. Wait, I can of course do it like this, but I still of course for some later use would like to get rid of this pin here. Yeah, I need to apply a bit more force. Just a second. empty to the other side, so the question is whether I can pull it out or whether it will not move still. Yep, it's up. I just hope it is still straight. Yeah, looks good. Okay, so we got this. Now we can just remove this part, and we are in. Yeah, we have here a nice stepper motor. So as expected for the scanner, they went with a little bit more elaborated drive system. I mean, on a printed page, if there is a very small shift, you will not notice it that much, I guess. Then when you record something for permanent use, because a scanning image you may want to have a good quality and use it for long, for whatever, I don't know. Now this two axes are again with something that we don't want, but since it feels very much like rubber, I think I can, if needed, just cut it down somehow, remove it without too much work. The other one I showed you on the very beginning from the printer was made more with some. The material it was made, the thing on the axis was very hard, so I don't guess it could be easily removed without doing something that would probably also scrape the axis itself. It's interesting how much chokes they put into this machine. I guess they were very serious about not making any EMI interference anywhere. I don't actually think that for the operation of the printer scanner thing as such, the EMI would be that much of a problem. They just wanted to engineer it very. Oh, that will not fit through very nicely. Great. Next screw is underneath this axis. Oh, I mean underneath the ring that holds this axis. So yeah, it should be removable. Let's see later. Things really are not made to be taken apart again. We just, I guess, want you to get a new one if anything breaks. But on the other hand, there is not much that could break here. Yes. Well, I guess I can keep this thing in one part at least for now. Oh, that's nice. It change direction. Somehow it must be able to connect to this thing, but I'm wondering how that would work. But doesn't matter. good idea to do it actually. I will have to figure out how to remove this this part. Oh, that works quite nice. Yeah, that works actually very nice. Okay. Yeah, well, good enough. The other one I will just leave as it is, as we should continue with the other parts. Screws there. And then we have a second one. Well, the display seems to have some low pin count connection. I will Google the model number later, maybe I can do something useful with it. And there are not much more cables going in, just about 5 wires. There is apparently a microcontroller that will drive the display and read out the keypad. We have 3 more screws we have to open in order to access the sides. I hope that for all screws. Looks like it's holding down somewhere still. Yep. in. Now there are really not much more components here, just a motor and the scanner head. And it looks like the scanner actually uses already LED light. There is no inverter anywhere, so it's not that old machine. And that's it. And that is the end of it. I'm wondering if the scanners can easily be read out somehow, like one could use them for something. I mean, I guess it's possible. We have a model number. It is a different manufacturer, so there will be, I guess, a data sheet describing how to operate this. So it might be worth a try, although I'm not sure for what purpose one would want to do that. And of course, the next question it poses is if one can do it with a low speed, like using microcontroller, if the data rate is somewhat fixed by the design. I would guess it should be doable to operate it at any velocity, but I don't know. Well, that was the end of it. We have took it apart completely with some screws still in, but other than that, it's that was it. So thank you for your attention, and we may have another printer to disassemble soon, but I'm not sure about it. I have to first check whether I can make it run or not.